Good morning to all. The topic of lecture is phase diagrams. Here we'll see what is solid solutions and its types, Hume-Rothery's rule, phase diagrams and its importance. What is alloy? It is a mixture of two or more elements which has metallic properties. The major element is a metal and the other element may be a metal or a non-metal. Solid solutions. A solid solution is the simplest type of an alloy. It is simply a solution in a solid state. It is defined as a homogeneous mixture in which the atoms or molecules of one substance are dispersed at random into another substance. Components of solid solution. The solid solution consists of two components, namely solute and solvent. Solute forms the major portion and solvent forms the minor portion of the solid solution. There are three possible solid solutions based on the amount of solvent and solute elements: unsaturated, saturated, and supersaturated solid solutions. Types of solid solution. The solid solutions are of two types based on the position occupied by the solute atoms in a solvent: substitutional and interstitial solid solution. Substitutional solid solution. When the solution atoms replace some of the solvent atom positions, then it is called as substitutional solid solution. For example, silver and gold atoms. Interstitial solid solutions. The solute atom does not replace a solvent atom, but it enters in the interstitial space available. Here you can see the substitutional and interstitial solid solutions. Next we'll see what is Hume-Rothery's rule. This rule states that two elements must be very similar to each other to form a solid solution. The elements must have the same crystal structure, atomic size, valence and electronegativity. Then we'll see what is phase. It is a physical and chemically homogeneous part of a system under study. The phase requires a unique structure, uniform composition and well-defined boundaries. Phase rule or Gibbs phase rule. It gives a relation between the number of phases, components and variables of a system. F is equal to C minus P plus N, where F is number of degrees of freedom, C is number of components in the system, P is number of phases in the system and N is number of variables in the system. The advantages and uses of phase rule. It is used to find the number of variables, components, phases and degrees of freedom. It says the behavior of the system with respect to composition, temperature and pressure. It indicates the behavior of the different systems under same condition. Limitations of phase rule. It is applicable only for single equilibrium state of the system. It considers only the intensive variables like temperature, pressure and composition. Then what is phase diagram? It is a graphical representation formed by plotting the values of independent intensive variables like pressure, temperature and composition for equilibrium condition between two phases. The uses of phase diagrams are: it is used to calculate the relative amount of phases in a two-phase alloy. It is used to find the freezing or melting point of the system. It is used to find the phase transformation and microstructure of the system. And finally, it is used to find the number of phases and composition of the system. Limitations of phase diagrams. It does not give the information about the size of the micro-constituent, physical and mechanical properties of the materials. With this, we'll conclude what is phase diagram and rules of phase diagrams and the importance and limitations of phase diagrams. Thank you.